We shall proceed to explain the how-to of insurance company stock shorting post-Los Angeles fires using Python, SQL, and AI. Welcome to this educational and insightful video, specially tailored for investors, data enthusiasts, nerds, good-looking people, traders, or all of the above. Remember, these are purely hypothetical constructs used for learning and may be morally unaligned, as these are thought experiments and may hurt some people's delicate feelings. A sincere apology in advance. Today we will explore how to analyze insurance stock trends after fire disasters in Los Angeles using Python, SQL, and AI. By the end of this video, you'll understand how to source, analyze, and visualize data to draw meaningful investment insights. Let's get started. Natural disasters can have a profound impact on people, but most importantly for this video, on the stock market and particularly in the insurance sector. I mean, who is going to pay the $50 billion? Not me. Fires in regions like Los Angeles drive insurance companies to face potential claim surges, often triggering volatility in their stock prices. This video aims to help investors leverage data tools to analyze patterns in this sector and turn uncertainty and chaos into wonderful opportunities. The first step of our glorious and delightful journey is data collection. The quality of your analysis depends on the depth and accuracy of the data you gather, so let's take a stroll through the key sources. We shall use public APIs such as Yahoo Finance to retrieve historical stock price data and financial performance metrics. FEMA's API provides incident reports and disaster data related to fires. These are incredibly valuable for understanding how these ostensibly random incidents correlate with market changes. Insurance company filings, financial filings, earnings reports, and disclosures directly highlight a company's response to fire-related claims. Geographic fire data incorporate data sets that track which areas were most affected by the fires. Sources like government agencies often release regional heat maps and data sets for this purpose. Web scraping. When data isn't readily available, Python tools like Beautiful Soup allow you to scrape supplemental information from credible sources, such as news websites or local government platforms. By amalgamating and integrating these sources, like mixing a pot of gumbo, we can create a consolidated data set for our gratifying analysis. After collection comes the processing. Data from multiple sources is often messy, grubby, and mucky. Cleaning it properly ensures accurate and reliable results. Let us start by handling missing values and duplicates within your datasets. Use Python's Pandas library to clean, sort, and format the data into useful structures. I'll provide the code for free use on the link below. Assume that your dataset shall be in CSV format. You will import pandas, load the dataset, check for missing values, handle those missing values, check for duplicates, remove duplicates, sort the data, reset the index, save the cleaned data. After handling missing values and duplicates, the next steps is data mastery focus on transforming, enriching, and analyzing your data to extract meaningful insights. The steps are 1. Data exploration 2, feature engineering 3, data enrichment 4, data visualization 5, advanced data cleaning 6, data aggregation and summarization 7, preparing for machine learning 8, automating workflows 9, real-time data processing 10, documentation and sharing. Analyzing insurance stock shorting post-fires using Python, SQL, and AI. Insurance stock prices, claim amounts, and fire frequency data may vary significantly in scale, like Olivier Rioux playing on the junior varsity basketball team. Take that data and make them normies. Normalizing variables ensures we're comparing apples to apples. Even French apples, despite tasting the best, are still apples and are not oranges. Python libraries such as scikit-learn's pre-processing module make this simple to implement. Just like Super Soaker inventor Lonnie Johnson is an outlier for IQ. Always validate the quality of your data by checking for outliers or inconsistencies that could skew the analysis. Plot initial trends to inspect for anomalies. With proper data that has been cleaned, scrubbed, and polished in hand, we can begin our preliminary exploration to identify potential stock trends. Visualizing descriptive statistics can reveal initial patterns. Use libraries such as Matplotlib or Seaborn to generate stock performance charts before and after fire incidents. For example, line charts showing stock price trajectories. Heat maps depicting fire-affected regions overlaid on insurance company headquarters will be a great visual to see which companies to short or to place a put option on, but that is for another video. SQL shines like a supernova while working with structured data sets, but MongoDB, Cassandra, and Hadoop are better for unstructured. Query your tables to isolate relevant time periods or stock activities affected by fire events. For instance, let us write some sexy SQL examples because whoever said SQL code is not sexy was wrong. It is. Analyzing insurance stock shorting post-fires, using Python, SQL, and AI. But of course, SQL seamlessly integrates with Python for combined analytical power like a Cray 1, if today we're 1976, making you the boss. Analyzing how specific fire-affected regions overlap with customer density provides an edge like an NSA analyst. Use tools like GeoPandas and Folium to create geographic overlays of fire zones and insurance claims. Remember, geospatial data may be the ticket here. This step is where we apply analytical rigor and David Goggins-like discipline to identify trends, shorting activity, and predictive opportunities in the insurance sector. Once the fires are reported, some investors initiate short selling, a strategy betting stock prices will drop. Python libraries like iFinance can help track shorting volumes during these critical periods. Examine patterns around sudden bursts in trade volumes against major fire dates. Analyzing insurance stock shorting post-fires, using Python, SQL, and AI. Let us peruse more examples. You learn by doing. The free use code is provided in the link below. Analyzing insurance company stock shorting post-fires using Python, SQL, and AI. Examine how claims filings, fire intensity, and stock prices interrelate like European royalty marrying their cousins. Compute correlation coefficients using Python to identify how sensitive stock prices are to fire activity. While the broader market might react to disasters, insurance stocks experience somewhat of a particular and unique type of volatility. You need to segment your data to differentiate between generalized market trends and insurance-specific behaviors. Artificial intelligence adds a heightened degree of sophistication to the analysis, sort of like educating on and about British etiquette to former savages by helping to predict stock movements or classify risk levels. The behavior is no longer wild and random, but with much focus. The models want data just like the strippers want cash. Feed historical data into machine learning models to predict how stocks might behave during future fires. Is the behavior hot or not? Features like fire severity, frequency, and geographic spread can be great predictors. Random forest and gradient boosting are recommended algorithms for their accuracy and robustness. Classify stocks into high-risk and low-risk categories post-disaster using supervised learning methods. This provides investors with actionable groupings that align with their risk tolerance, so investors can take massive action with the insights instead of watching videos all day. Good models always undergo rigorous validation to ensure accuracy, just like Insta-influencers that transition to OnlyFans and make millions. You need to spread it apart and split your dataset into training and test sets to avoid overfitting the model. Perform hyperparameter tuning for optimal performance. After completing the analysis, consolidate your findings into actionable insights. It's of no use to spend the time knowing these insights if you do nothing about it. You need to summarize significant takeaways, make a synopsis of the movie, its plot, characters, and key points, things people will likely remember, so that massive action can be taken. Insurance stocks often dip briefly before recovering after disaster-related payouts. You need to know how briefly the dip will be before the recovery, recognize signs of relapse into non-sobriety. Do you even lift, read the charts, understand technical analysis, utilize AI? What are the triggers for a quick recovery? The magic is in that dip. Turn it into gold like alchemy. Regions with extreme fire damage and high insurance claims correlate to stronger shorting activities. The data speaks to us like Pythia, the Oracle of Delphi. Now you have had an epiphany. Predictive AI models effectively pinpoint stocks likely to underperform immediately after large-scale incidents. You can add value to our great society by analyzing a real-life case of Los Angeles fires, highlighting how a prominent insurance company's stock reacted to publicized claims. This reinforces theoretical insights with tangible results. You need to hold on to what is tangible. Theory is for scientific papers. Finally, present your findings in a way that captures attention like Zoltar, the pirate fortune teller, that simplifies interpretation. Visualize that data. Most of the unwashed masses, like pictures and stories, make it simple, like reading to a child or your boss. Turn complex data into interactive dashboards with visualization tools like Tableau or Python's Plotly. Display trends, geographical maps, and performance metrics in user-friendly ways. Package your insights into a presentation with compelling visuals to enhance decision-making. Use clear, actionable language to communicate your conclusions and their implications for the profiting off shorting insurance companies. By combining Python, SQL, and AI, you now have the tools to analyze insurance stocks with precision after major fire incidents. We've covered data collection, processing, exploration, and advanced predictive modeling to provide valuable insights, and we have not taken our clothing off. We hope this equips you with skills to transform raw data into actionable investment strategies, hoping these skills will impress your boss or your significant other, maybe make you more money, but spurring you to take massive action. Like and subscribe to this channel for more analytical and hopefully fun content, and join us next time as we continue exploring technology's role in the financial world. See you soon.